So today we will deploy changes to Kubernetes cluster. We will see the deployment process, as well as we will see scaling. Also we will see rollback to a certain code version. So first let us check the app. So here is the app on your screen right now. So here in the docker the app.js file contains the code. So we will just build the code and run to show you what is the output. So first we will log into the docker hub. So here we can see that we are trying to log in with our saved login and password. Now we will build the image. Now we will just build the image. Just we are logging to see the docker hub, the repository name, because that name needs to be there on the image file. So here is the command sheet. I will just copy and paste it to the notepad, because in Word it does certain formatting which is not good. Actually it is very error prone, so we will just change it a bit. Yes. So we created a deployment just to show what is the output. It is on the Kubernetes cluster right now with the image name. It's just increasing the font a bit. So here we have started the Kubernetes cluster. After the deployments are done, so this is the deployment done in last screen. Now we will open the dashboard to see if the status of the deployments, the status of our clusters. So it is not yet done, it is in process right now. So let us wait for a while. It will these three dots will go green. So we can now see that the deployments, yes, now all has turned to green. So if we yes, so we had just created a deployment. Now we will expose the service. So we will just expose the service of the deployment. If somebody wants to view the details of this part of this project, they can go and see our earlier video. There we have explained the types, the load balancer, and how to create deployments, what are the nitty-gritties. Okay friends, please, if you find this video and the other videos all are all are helping you a bit, so please support us by subscribing and liking this video, subscribing to our channel. So there are certain typos, we will just correct it and run. Yes, so the service is exposed. It is just copy and paste error, my friends. So once you get into Word, it just creates one minus out of two minuses. So this is the service we have just exposed. We will just open another window to just access the portal from outside the Kubernetes cluster. So it is just a single command, that is minikube service. This one we must give. So we just, it is minikube, then service, then the deployment name. So that needs to be passed on at command prompt to minikube cluster, so that we get the service up and running and access the portal. So it will just open. Now you can see it is opening. So this is the actual Node.js app. This Kubernetes dashboard is up and the service is exposed on the local machine. Now we will try and update the code. Okay, first of all let us test the scaling. So we will scale it. We will create 3 pods. Actually we will create load balancer. Load balancer is already created. To demonstrate the functionality, we will create 3 pods, 3 replicas of our current deployment. So we can see the command, it is scale, it is kubectl scale, then deployment name, then minus minus replicas, and equals to the number of pods we want to create. So we can see that there are 3 pods. We have created 3 replicas. Yeah, so we can see 3 pods up and running. And if we just type on the application name or application URL, so here we are crashing the app, /error crashes the app, but we can see that 3 pods are already up. So it is just this is the functionality of the here we can see that it is trying to spin up an app, as there is an we have triggered the app crash, but one will always be running. So we can see that it is still up. 1 pod will be up. We have been able to crash 2 of them, but 1 is up still. So this is fault tolerance and load balancer in display. Yes, now we will just scale it down to 1, replicas to 1, so that the rest we can just increase a bandwidth of our machine, although it's a test machine, but still. Again friends, please if you have seen the video till now, please subscribe and like the video. So we can see 1 pod is up, the rest is down, and the app is still running. This thing will also just go green. Yes, so it is just it has just adjusted to its default configuration, that is 1. And if we crash that, we are crashing it, see it is crashed, it has gone red, but it will be up again very soon. So this is the fault tolerance in play. Yes, it has now turned green. So now we will update the app and try to push that as a deployment. So we are adding another line to the heading and just entering a random text, sorry. So here we just added a line. We will save the code, we will rebuild it and push it. we will tag it with version number 02. Earlier was version number 01. If you want to see, you can go back to our earlier video where we have demonstrated this functionality. So we are now building the image. -t means it's a tag, that's the image name. We need to give the repository name and the tag over here. Tag means the version number, so we will give it 02 as 01 is already on the repository, and then we provide dot so that it compiles the Docker file. So it is still on. Okay, it's going on the build process. So build is successful. Now we will push this image. First let us run it in the local machine and see how the change goes. So we will run it with docker run command. Just a container name and the required flags /d -d as detached and --rm as remove when it is not running. So it will just remove the container when the container is brought down, so that we doesn't have too many containers running on the system when they are not needed. So it is an error because we have to put ---- name. I have put only -name over here. Yes, so it shows that this one is up. Yes, here we can see it is up. So we will just here is the container that is running. Yes, so we will go to the local host and with port 8080 there is a typo. Yes, so we can see it is adding the change. So this is the change, and this was the original Kubernetes app. So we will push this image, push this changed image to Docker Hub. We need to change the name. Yes, there were a lot of typos because it was running on local. It didn't have any problem, but whenever when we push it onto the Docker Hub repository, the image, then we need to conform to the Docker Hub naming standards or the naming conventions we have followed over there. So it's the difference. 260977 was added. Now we will push the image. The copy paste. Yes, so we can see the pushing is going on. Yes, there are 3 lines of change, so those 3 lines have been added on the image and it is getting pushed. So there are 4 pushes actually, 3 plus 1. Yes, Right now only one image is there, but after push is complete we will see two. So, yes, so here we can see push is complete. Yes, now we can see, we will just refresh it. So there are two images. One is, that is the 02, it has a few seconds ago. So now we will just update the deployment with this changed image. Please remember to follow the conventions. Then the command is kubectl set image, then the deployment name for which you are changing the image. Then you will have to put on the container name. Yes, the container name then equals to, yes, the changed name. So cub01 is my container name. So we can see that deployment cub01 image is updated right now. So we will just see if the status of the deployment after the update. So it is the rollout status. So here everything is fine, so we will just check for the rollout status. So here is the deployment. It has been pushed, and we can see that one image is getting terminated, another one is getting populated. So one is running and another is terminated. Okay, now we will try to deploy an error, that is a false image, but before that we will check the rollout status. Again there is a mess, we need to put the deployment name. So it says rollout is successful. Now we will try to put a bug so that we can demonstrate the functionality of rollback. Yes, so here we are putting a wrong image name so that it fails. Here we can see that waiting for deployment cub01 rollout to finish. It is still yet to terminate one of the old replicas, because the image tag we have intentionally given as 03. There is no 03, but the app is still up because it has kept one node up. It has kept one single node up. It was trying to change, but as it was in error, so it didn't push. So now we need to roll this one back so that, yes, you can see that it is still waiting for deployment cub01 rollout to finish. So it is stuck actually. So we need to undo this. So the syntax here is rollout undo. So we can see that it is rolled back. Now if we go and see the local host, nothing has changed actually, but the red pods are right now green, so that there is no error. therefore there is no error. So now what we will do is we will try to move the code to an earlier version. We will try to roll back to an earlier version. So now we will check the rollout history of deployment comp01. Yes, see, we are seeing 3 revisions, 1, 3 and 4. 1 has been rolled back, so 2 is rolled back right now. 2 is deployed right now. 1, 3 and 4 still remains. So we can roll back to revision 1. So that we will do. Yes, rollout undo, then 2 revision, that is minus minus 2 minus revision equals to revision number. So we have rolled it back to revision number 1. That is the first instance. So we can see that 3, 4, 5 is up, but 1 is not there. So revision 1 is deployed. So if we refresh it, here we can see that the deployment has gone back to the first version that was deployed in the very beginning of this video. So that's it, friends. Thank you again. Please like, subscribe and have a good night.